Welcome to Lesson 9 of the Introduction to Python course. In this lesson, we will be discussing Python dates and times with a focus on the time module and the datetime module. Now, time is an important concept that plays a huge role in day-to-day life. When it comes to programming, it can sometimes be quite challenging to work with times and dates. Thankfully, Python has some great built-in functions and modules that can help us to work better in this area. Before we proceed, let's have a look at the way Python and similar programming languages understand time. Now we know that time zones can differ depending on continent, country, and even city. We also know that some places follow daylight saving time, but the time and date of its occurrence vary geographically. This can be confusing to keep track of, considering the fact that there are so many places spread out across the world. This is why, rather than using local times, we use Coordinated Universal Time, or UTC, which is the standard by which we measure time. It comes as a successor to Greenwich Mean Time. Now, in this diagram here, we can see the different world time zones as of May 7th, 2019 at 12:4830 hours. Now, computers use something called an epoch while performing calculations involving date and time. According to computers, an epoch is the moment that time began. In Python, the epoch is said to be January 1st, 1970 at midnight. This is written as 1970:01:01 space 00:00:00. Any time before the epoch is written internally with negative numbers. Now, Python has some extremely powerful libraries that can be imported into a program to provide some useful functionality when working with dates and times. We'll start with the time module. So the time module is used to access, manipulate, and compare dates and times. This is helpful especially when we are testing our code. So Python's time module has 4 types of clocks. First is the time.monotonic. Second is time.perf counter. Third is time.process time. And fourth is time.time. We'll see how these clocks can be used to measure absolute and relative time. Absolute time is the number of seconds since the epoch. This value can be converted into an actual time of day. Out of all the 4 clocks that the time module has, only time.time can measure absolute time. So let's take a look at this piece of code. So we will import the time module, and then we will define our first variable, which is seconds since epoch, which is time.time. Next, we have minutes since epoch, which will be seconds since epoch, divided by 60. Then we have hours since epoch, which is equal to, which is equal to minutes since epoch divided by 60. Then we have days since epoch equal to hours since epoch divided by 60. Sorry, 24. I realize it's days. Then we have years since epoch, which will be days since epoch divided by, I'm sure you know this, 365.24. 25, sorry. Then we have print, colon, flower braces, colon, comma. And then we have month, flower braces, colon, comma. We have hour, flower braces, colon, comma. We have day, flower braces, colon, comma. We have year, flower braces, colon, comma. Then we have dot format, seconds since epoch, minutes since epoch, hours since epoch, days since epoch, and years since epoch, followed by the separator, which in this case will be a new line. All right, now let's print this out and see what happens. So here, as you can see, we calculate the seconds, minutes, hours, days, and years since the epoch. Now, we use time.time to calculate the number of seconds, which we then use to estimate the rest of the values. And just a side note here, in case you're wondering why this little gap happened, that's because I put this space over here. If there was no space here, all of these would be perfectly aligned. All right, so now we will move on to relative time. Relative time can be calculated from an unspecified start time with the help of the other clocks that are used by the time module. So this is helpful when we want to find the differences between some moments in time. The time.perfect counter clock provides the most accurate results, and so it's usually used when we want to determine the execution time of some given code. Now let's see an example for this. So let's say that we want to create a random list of integers between 1 and 100. And then we want to output this list as a string. Now one way to do this is to create a loop that concatenates a new randomly generated number onto our string with every iteration. The problem is this method is not very efficient. It would make much more sense to just create a list, append a random number to it with every iteration, and then join the list to a string once the loop is complete. So using this comprehension would make this process even quicker. Now let's try this out. Let's actually try this code out. So we will import time first, and then we will import random. Next, we have iterations equal to integer, and then input, and we input the number of iterations from the user. So now we will start the process of concatenating strings. So we have start time equal to time dot perf counter. Then we will have numbers equal to, that's it. We just leave this as it is. Then we have for I in integers, sorry, for I in range iterations, num is equal to random dot random integer between 1 and 100. So this randomly takes some value somewhere between the range of 1 and 100. And it stores this number in the variable num. Then we have numbers plus equal to, comma, plus string num. Then we have end time equal to time dot perf counter. Then we have TDL equal to end time minus start time. Next, we will append to a list. So first we concatenate the strings, and then we append to the list. So we have start time equal to time dot perfect perf counter numbers equal to some empty list. Then we have for I in range iterations. Num is equal to random dot rand int 1 and 100, and then numbers dot append string num. So we append the num value to the numbers list after converting it into a string. Then we have numbers equal to, comma dot join numbers. Then we have end time equal to time dot perf counter, and then td2 end time minus start time. All right, so next we would have using list comprehension. So we have start time equal to time dot perf counter. Then we have numbers equal to string random dot rand int 1 and 100 for I in range, right? For I in range 1 comma iterations. Then we have numbers equal to comma dot join numbers. Then we have end time equal to time dot perf counter, and then td3 end time minus start time. Then we have print f Then we have number of numbers, iterations. We have time delta 1, TD1. We have time delta 2, TD2. We have time delta 3, TD3. Then we have TD1 is round, TD1 by TD3, comma 2, times slower than TD3. New line. And that's it. So let's run this code. It asks us for a number of iterations, so let's just put in 3. All right, so of course there's an error. It says TD1 is not defined. Now that's true because I accidentally wrote that as TDL. So now if we run this again, number of iterations 3, and it gives us this value. And then it tells us that TD1 is 1.38 times slower than TD3. So one thing that we can see here is that the speed differential increases notably while we work with huge amounts of data. All right, so next we will talk about time structures. Now time can be expressed as a time.structTime object, which is basically a type of tuple. For the epoch, this object would look something like this. So we have time dot struct underscore time tm year equal to 1970 pm month equal to 1, which is basically January. Then we have tm m day equal to 1. We have tm hour equal to 0. We have tm minute equal to 0. We have tm second equal to 0. We have tm w day equal to 3. We have tm y day equal to 1. Then we have tm is dst equal to 0. Now, just for you to understand, since you probably did not understand what all of these are, so we have TM month, which is January. TM year, of course, that is easy to understand. We have TM M day, which is that particular day. We have TM hour, we have TM minute, we have TM second, and we have TMW day, which would be 3. 3 is equal to Thursday because 0 is considered as Monday. And then we have TMY day, which is 1, which is basically the first day of the year. And then we have PM is DST, which is it daylight savings or no daylight savings time? So we put 0 because there are no daylight savings time. Now, the same time can be written as a string like this. So this will make a lot more sense now. So Thursday, Jan 1st, 0 hours, 0 minutes, 0 seconds in the year 1970. So this is the day of the week. This is the month. This is the date. This is the hours, minutes, seconds, and this is the year. So now this probably makes a lot more sense. So when you actually compare each of these, so we have the year here, we have the month here, we have the day here, we have the hours, minutes, seconds, 0 each. Then we have the weekday, Thursday, we have the date, which is Jan 1st, and we have DST, which is basically 0 here because this does not have DST. Now there's some methods that create time.struct_time objects. And these include GM time and time.local time. So we have time.gm time in which we pass seconds as a parameter. Now to check if our time zone follows daylight saving time, we can use this command. So we say time.local time .tm is DST. So when we execute this, we get 0. That's because the time zone I'm in, which is India, does not follow daylight saving time. Now the inverse of time.local time is time.mk time. This command takes a struct time and then returns the value of the number of seconds since the epoch. So we will try the code. We have LT equal to time.local time, and then we have LT. Right, so if we print LT, okay, my bad. I forgot that's here. There we go. Now we get the value that we want. So now we can do seconds since epoch equal to time dot mk time local time, and then we print seconds since epoch. As you can see, the tiniest of things create errors in Python. So as I always say, be very careful while you're programming. All right. So now let's take a look at times as strings. So when performing calculations or comparisons, it's useful to have the dates and times as objects or numbers. Otherwise, it's better to output them as strings. Now, some methods that are used to express these values as strings include time.asTime and time.cTime. Let's get a little more into both of these. So the time.asTime method converts a struct time into a string. If the struct time argument is not fed to it, it defaults to the time.localTime, which would return the current local time. So we have time.asktime time.gm time 0. So this is the string representation of the epoch. Now, if we want a string representation of the current local time, we would just say time.asTime. So this gives us the string representation of the current local time. Next, we have time.cTime. So this converts time that is expressed in seconds since the epoch into a string. If the seconds struct time argument is not provided, it defaults to time.time, which would return the current time in terms of seconds since the epoch. So for example, if we have string epoch offset equal to time.cTime 0, we are providing the argument. Then we have string epoch offset, which prints this out. Now if we say string now equal to time.cTime without providing any argument here, and we print string now, we get the current local time. Now we will go through time and formatted strings. So first we have time.string format time with format and in brackets t. This takes a struct time object and returns a formatted string. Second, we have time.string parse time with string and format in the brackets. This takes time expressed as a string and returns a struct time object. We also have some formatting directives that are used when working with dates and times. Some of the common ones are listed here. So as you can see, there are quite a lot of them. So we will just very quickly run through them. So we have percentage small a abbreviated weekday name, percentage capital A is a full weekday name, percentage small b is abbreviated month name, percentage capital B as full month name, percentage small d as day of the month as a decimal number, percentage capital H as the hour in a 24-hour clock as a decimal number, percentage capital I hour in a 12-hour clock as a decimal number, percentage small j, day of the year as a decimal number, percentage small m, month as a decimal number, percentage capital M, minute as a decimal number, percentage small p, locales equivalent of either AM or PM, percentage capital S, second as a decimal number, percentage small w, weekday as a decimal number, percentage small x, locales appropriate date representation, percentage capital X, locales appropriate time representation, percentage C, locales appropriate date and time representation, percentage small y, year without century as a decimal number, percentage capital Y, year with century as a decimal number, and percentage capital Z as time zone name. And there are no characters if no time zone exists. So let's try using the string format time and string parse time methods along with some formatting directives in a program. So we will import time, of course. Then we have epoch equal to time.gm time 0, print time.string format time percentage C, comma, epoch, we will basically be using the same thing for a while. So we have this, and then we will say percentage X, paste this again, we will have percentage capital X, and paste this again. This time we have percentage capital A, percentage capital B, percentage D, percentage Y, capital Y, percentage capital I, colon, percentage capital M, and percentage small p. Yeah. And then we will say American Independence Day, time dot, string parse time, 07, 04, 1776, following the American date format. Then we have percentage month, percentage day, percentage year. Then we will print Independence Day. So when we execute this, this is the output that we get. So we get Thursday, Jan 1st, 12 hours, minutes, seconds, and 1970, which is the epoch. Then we get this in date format, the date rather, and we get the time separately. Then we get this. Now there is an error which we would need to correct. So let's just give this a minute. All right, so the error is here. Accidentally put in a comma. So now when we run this, we still get an error. So let's try to clear this output and see what happens. Right, we still get an error. So we'll look into that. Okay. Once again, very trivial thing, but makes a huge difference. There we go. Now this is the output that we wanted. So this is how we can use time.string format time and time.string parse time, along with some formatting directives, to write a program that involves date and time. Now we'll see something that's really interesting that comes with the Python date and time modules. So we can temporarily suspend the execution of our code for a specific number of seconds using the time.sleep method. Let's see this in an example. So we will import time first. Then we say for I in range 10, 0 comma -1, which is basically a countdown. We print I, and then we have time.sleep 0.5. And then we print blast off. All right, so when we execute this, let's see what happens. Now, just so that you know, I did not do anything here. All I did was execute the line of code, rather the piece of code, and after that, the countdown happened all on its own. So every 0.5 seconds, a number was being printed out between this range. And since it was counting backwards, it went from 10 to 0, and we gave a step size of -1, and then we printed out the number one by one. And at the end, we say blast off. This is pretty cool, isn't it? Now, time.sleep can also be used to simulate a digital clock. We can use this to output a new time every second until the user prompts the computer to stop by pressing Ctrl+C. So let's try this again. Now we will define start clock as our function, and then we will print starting clock. Actually, let's not put the call in there. All right, then we will say try. While true, local time equal to time.local time. We have result equal to time.string format, string format time. And then we pass in these arguments. So we have percentage capital I, we have percentage capital M, and we have percentage capital S with percentage small p, comma, local time. Then we will print result, and we have time.sleep 1 except keyboard interrupt, and then we print stopping clock. And that's about it. So now when we call our function start clock, as you can see, it is printing out a time one by one by one. It's basically printing out a time every second. Just press this button and it will stop. It's pretty interesting, right? So this is how we can use time.sleep to suspend the execution for a certain number of seconds. So what we have seen so far is how we can use Python's time module to perform calculations, comparisons, and manipulations with date and time objects. So we will now have a look at another module in Python called the datetime module. Now the datetime module has the following types. So first we have datetime.date, which is a date with the year, the month, and the day attributes. Next, we have datetime.time. This will be a time with the hour, the minute, the second, the microsecond, and the time zone information attributes. Third, we have datetime.datetime. This is kind of like a combination of datetime.date and datetime.time. And fourth, we have datetime.time delta. So this is a duration expressing some kind of a difference between two instances of datetime.date or datetime.time or even datetime.datetime objects. So first, let's have a look at datetime.date objects. First, we have datetime.date with a year, month, and day given in the brackets, which would create a local date. So we will import datetime, then we will say datetime.date 1776 74. So we get this. This creates a local date. Then we have datetime.date.today, which returns the current local date. So we have datetime.date.today, and this gives us a current date. So it's the 24th of June, 2022. Finally, we have datetime.date.fromTimestamp with seconds given in the brackets. This returns a local date from a specified value of seconds since the epoch. So let's say we have week in seconds, which will be 24 times 60 times 60 times 7. Then we have datetime dot date dot from timestamp, and then we have week in seconds. All right, there was a spelling mistake here. There we go. So we get the week in seconds. Next, we have datetime.date attributes. So this has some attributes like year, month, and day. We'll see this in an example. So if we have I_day equal to datetime.date, and then we pass in 1776, 7, and 4. Then we have iday.year, comma, iday.month, and iday.day. When we execute this, we get exactly that, the year, the month, and the day. Now we have datetime.date methods. So datetime.date instance has the following methods. So we have replace, which would return a new datetime.date instance based on the date with the given replacements. So we have Independence Day or I-Day equal to datetime.date, and then we pass in the information, 1776, July 4th, okay. And then we have I-Day dot replace, and we say year equal to 1826. So you can see that we get a change in the value here. 7076 becomes 1826. Next, we have time tuple. So this would return a struct time. So for example, we have iday dot time tuple. So you can see we get the struct time. Then we have weekday, which returns an integer that represents the day of the week. So very simply, if we just say iday dot weekday, this gives us 3. And if you remember, 3 is Thursday because we start with 0 as Monday, 1 as Tuesday, 2 as Wednesday, and 3 as Thursday. Then we have ctime, which returns a formatted date string. It's similar to ctime with the time module. So we have iday dot ctime. So this gives us Thursday, July 4th, midnight, 1776. Then we have string format time, which returns a formatted date string. So it's kind of similar to what we have learned before, with the same formatting directives as well. So we have iday dot string format time, and then we can just specify percentage capital A, percentage capital B, percentage small d, percentage capital Y, percentage capital I, colon, percentage capital M, and percentage small p. So when we print this, we get Thursday, July 4th, 1776 at 12 a.m. So we will now have a look at datetime.time objects. So we can create datetime.time objects with the help of the datetime.time method. This takes in these arguments. So we have hour, minute, second, and microsecond, which all default to 0. And then we have time zone info, which defaults to none. So this would make the datetime object naive, which means that it's unaware of time zones. Now we can set the time zone info to UTC by typing in time zone info equal to datetime.timezone.utc. Now we also have datetime.time attributes, which include hour, minute, second, and microsecond. So for example, we can have t equal to datetime.time hour equal to 14, minute equal to 13, second equal to 12, microsecond equal to 11, tz info equal to datetime dot timezone dot utc, then we have t dot hour, t dot minute, t dot second, t dot microsecond, t dot tz info. So when we print this, these are the values that we get: the hour, the minute, the second, the microsecond, and the time zone info, which is all what we have set here. Next, we have datetime.time methods. So these include the following methods that we will be seeing. So we have replace, which would return a new datetime.time instance based on time with the given replacements. So let's say we have the same thing. We can just copy and paste this here. And now we will say t.replace, and then we will specify that the hour needs to be 4. So when we run this, you can see that instead of 14, it now becomes 4, and then the rest of it remains the same. Next, we have string format time, which returns a formatted date string, which is similar to what we've already seen with the same formatting directives. So once again, just a demonstration, we have t dot string format time, and inside we will pass in the arguments percentage capital I, colon, percentage capital M, space percentage small p. So this prints out the timing to 13 p.m. Now we'll talk about datetime.datetime objects. So what is a datetime.datetime object? It's basically a combination of a datetime.date object and a datetime.time object. So we can create datetime.datetime objects in these ways. So first we have datetime with year, month, day, hour, minute, second, microsecond, and time zone info passed in as arguments, and this would create a new datetime. Then we have datetime.today, which returns the current local date and time. We have datetime.now, which would allow for the time zone to be set, and otherwise it's similar to datetime.today. Then we have datetime.utc now, which would return the current UTC date and time. Then we have datetime.fromTimestamp with time zone passed in as an argument, which would return the local date and time corresponding to the timestamp. Then we have datetime.udc from timestamp. Timestamp is the argument again, and this will return the UTC date and time corresponding to the timestamp. Then we have datetime.combine, datetime.date, and datetime.time. So this would combine a datetime.date object and a datetime.time object into one single datetime.datetime object. Then we have datetime.string parse time with date string and format as the arguments. This would take a string representing a date and time and would return a datetime.datetime object. Now let's take a look at some datetime.datetime attributes. So these basically include the year, month, day, hour, minute, second, and microsecond. So let's test some of these out. So let's say we want to talk about the day of the moon landing. So we will have moon landing equal to datetime.datetime, and then we have the year equal to 1969. We have the month equal to 7. We have the day equal to 21. We have the hour equal to 2. We have the minute equal to 56. We have the second equal to 15. Then we have time zone info equal to datetime.datetime. Sorry, this would actually be datetime.timezone .utc. Then we have moon landing .year, moon landing .month, and and moon landing .day. So when you execute this is exactly what we get, 21st of July, 1969. Now we can print out moon landing .hour, moon landing .minute, and moon landing .second. So we get 2, 56, and 15. Now let's see what happens if we ask for moon landing .microsecond and moon landing .time zone info. So the microsecond was 0, and the time zone is UTC. So this is how we can use datetime.datetime attributes. Next, we have datetime.datetime methods. So datetime instance includes the following methods. We have datetime.replace, and we can pass in any of these arguments. And this would return a new datetime.datetime instance based on the datetime with the given replacements. So for example, let's say moon landing dot replace, replace, and then we say year equal to 2019. So now you can see that this becomes 2019 and the rest of the information is the same. Likewise, datetime.date, this would return a datetime.date object with the same year, month, and day. So we can have moon landing dot date. Then we have datetime.time returns the same object with same hour, minute, second, and microsecond. So we have moon landing dot time. Then we have datetime dot time tuple, which would return a struct time representing the local time. So for example, if we have moon landing dot time tuple, this is what we get, the struct time. Then we have datetime.utc time tuple. So this would return the struct time, but representing the UTC time. So we have moon landing dot UTC time tuple. Then we have datetime dot timestamp, which would return a timestamp corresponding to the datetime. So we have moon landing dot timestamp, and this is what we get. Then we have datetime.weekday, which returns an integer representing the day of the week. So we would say moon landing dot weekday, which is 0, which was basically a Monday. Then we have datetime.ctime, returns a formatted date string, which is similar to what we've seen before. So we have moon landing.ctime, and this is what we get. Then finally, we have datetime.string format time, which returns a formatted date string, and it's similar to what we've seen before. So we have moon landing dot string format time, and we have percentage capital A, we have percentage capital B, percentage small d, percentage capital Y, percentage capital I, colon, percentage capital M, and percentage small p. So it's Monday, July 21st, 1969 at 2:56 a.m. So now let's try an exercise that is kind of similar to what we did before, but here we will write a program to determine what color pants need to be worn based on the season during the specified date and time. So that's basically the problem statement that we need to work with. So yeah, let's start with our program. So we will say from date time import datetime. Then we define is summer, and we have the date equal to datetime dot now. So first we need to get the year of the past in datetime object. So year is equal to the date dot year, Then we need to create a datetime object for starts of the seasons. So we have summer start equal to datetime year 6/20. Then we have fall start, which is again datetime, and this time we say year 9/22. So now we need to return true if the past and date is somewhere between the starts of the seasons. So we would return summer start less than the date, which is less than fall start. Then we define the main function, and we use ternary operators to assign the pant colors. So we will say pant color equal to white if is summer, else black. And then we print F, you should wear, in brackets, pant color, and then we continue pants. That's about it. Now we can call our main function and execute this. So it takes the local time and it says we should wear white pants because it is summertime. On the other hand, if it was fall, then it would say to wear black pants. Or if it was winter, for that matter. So that's about it. It's a very simple program, but it demonstrates how we can use the date and time modules to write code that incorporates date and times in Python. So now we will have a look at datetime.timeDelta objects. So these objects are used to represent some duration of time. So for example, we can find or we can represent the time between two date objects, or two time objects, or two datetime objects. So these datetime.timeDelta objects can be added, which would give a new datetime.timeDelta object. They can be subtracted, which would give, once again, a new datetime.timeDelta object. They can be divided, which would give a float. They can be multiplied by an integer or a float, which would result in a new datetime.timeDelta object. And they can be divided by an integer or a float to give a new datetime.timeDelta object. We have datetime.timeDelta attributes, which are basically days, seconds, and microseconds. So we have now equal to datetime.today. Then we have start time equal to now.replace. And we give hour equal to 8, minute equal to 30, second equal to 0. And let's also throw in microsecond. Equal to 0. Then we have end time equal to now.replace, hour equal to 8, minute equal to 48, second equal to 23, and microsecond equal to 0. Then we have race time equal to end time minus start time. And then we have race time. So when we print this, this is what we get, which is the time delta. Then we have race time dot days race time dot seconds and race time dot microseconds. This is what we get, the days, the seconds, and the microseconds. Now, unlike what we have seen so far, a datetime.timeDelta instance has only one method, which is the total seconds. And this returns the total number of seconds in the duration with microsecond accuracy. So let's say we have race time dot total seconds. So this would give us the total number of seconds. And in this case, the microseconds are not specified, they're just equal to 0. But if we had specified some microseconds, then that would be specified as well. Now we can find the time delta between dates. So this can be calculated by subtracting one from the other. So let's say we have start equal to date time, and we have year equal to 1861, month equal to 4, day equal to 12. Then we have end equal to date time, year equal to 1865, month equal to 4, and day equal to 9. Then we have delta equal to end minus start, and then we have delta days. So when we print this gives us 1458. So it basically subtracted the end from the start and then gave us the number of days, which is 1458. And that's about it. So in this lesson, we have learned how to work with dates and times in Python using the time and the date time modules.